Hi, Catherine. On section 9.8, problem Q4, what Dr. Forrester wants you to do here is, well, first of all, you look at it, the quadratic relation, and you think, okay, well, here it is. You have x squared, right, plus 5xy. That is the key right there. There is an xy term in this. Plus 9y squared equals 100. Now, because there is an xy term, all bets are off, right? You know, this should be an ellipse. Most of the time, this will be an ellipse. Because there's an xy term, it might be a rotated ellipse. Or if you look at what the discriminant is, and the discriminant, remember, is going to be, I think it's b squared. Excuse me, it's going to be b squared minus 4b squared minus 4ac. So it's going to equal b squared, which is, well, let's see, am I on the right one? This is Q3. Wait, Q4 is 6 right here, sorry. Let me switch this around. Q4 is 6. 6xy plus 9y squared equals 100. There you go. This is Q4. All right, so now let's see. B is 6. It's the coefficient of the xy. So it's going to be 6 squared minus 4 times a, which is a is the coefficient of the x squared term, which is 1, and c is the coefficient of the y squared term, which is 9. And there's a d, e, f if there are linear terms and things like that, but for the discriminant, this is all we care about. And you can just see this is going to be 36 minus 36. Discriminant is 0, and so then according to Dr. Forrester, this should be a parabola, which is not true. So if you feel like screaming and pulling your hair out right now, go ahead. Like I'm with you. So let me show you why this is not a parabola real quick. And now you could just shut it off right there and just say, okay, done with that. This is as much as I ever want to know about any of this. And I would totally get that. So go ahead and do that. But just in case you want to see the really, really fun stuff, we could solve this for y, right? If you were going to put it in the TI-84 on your handy-dandy y equals editor, then, you know, we have to do something here, right? We have to solve for y. So in order to do that, I'm going to get 9y squared here, okay? It's not as bad to follow as you think. Minus or plus 6xy. I'm going to just keep the y's together, and I'm going to take that x squared and move it over to the other side. Now I'm going to divide everything by 9, so I can get the y squared by itself, and I'm going to be able to complete the square then. So, okay, I'm going to divide everything by 9. 9, 9, 9, right? And so then I'm going to get y squared plus 2/3 x times y, and I differentiate it like that for a reason. Because what I'm going to do here, and this is the really sort of really tricky part here, I'm going to complete the square. Do you see what I'm going to do here? I'm going to complete the square. As a matter of fact, I'm going to, let me complete the square, and I'm even going to make this, let me squish this in right here. So when I complete the square, I can, whatever I add to one side, I can add to the other side. Well, complete the square, remember, I'm considering it's y squared, right? So this is the coefficient of y, 2/3 x. So do you get that? 2/3 x is the coefficient of y. So you're going to take half of that, half of 2/3 x, half of that is going to be 2/6 x, and then square it. So 2/3 x, half of that will be 2/6 x squared. And won't that be, am I right on that? Let's see, 3 goes into 6, 2 times 3 is 3, 9. 2/3 would be 2/6, but 2/6 is 1/3. Okay, so it's really just going to be 1/3 x squared. I don't remember did I get that on my little paper right over front of this earlier? Oh yeah, I did. I think I did. Yeah, I think I did. Okay, so it's going to be 1/3 x squared, which is going to be 1/9, right? 1/9 x squared. So that's what I'm going to put right here, 1/9 x squared, or x squared over 9. So that's what I'm going to put here, x squared over 9. Do you see that? I'm going to add x squared over 9 to both sides, because I completed the square. So what I add to one side, I have to add to the other side. All right, well, now all of this is going to factor into y plus 1/3 x, that whole quantity squared. This is just completing the squared. And this is going to equal, look what happens over here. Over 9, look at what I get. 100 minus x squared plus x squared. So it's just 100. 100 over 9. Look at that. X squared is gone. Honky-dory there, right? Now we're going to take the square root of both sides, positive negative square root of 100 over 9, which it's perfect square, by the way. So look at what I'm going to get here. I'm going to get 1 plus 1/3 x is going to equal positive or negative 10 thirds, right? And so finally, in the y is going to equal positive negative 10 thirds minus 1/3 x. Or, okay, look at the way we could write this. Y is going to equal negative 1/3 x. This is a slope-intercept form, right? Plus 10 thirds. It's going to equal that. Or y is going to equal negative 1/3 x minus 10 thirds. Those are the two lines right there. That's it right there. Those are the two parallel lines. And so this ellipse it rotates, and it also degenerates. You know, a conic section here. If you just think about it, the conic, it just degenerates to two parallel lines. How could it do that, though? Let's see. How could we? I don't know. Because you would have that right here, and maybe because no matter what, I'm going to crisscross on a line there. Well, it just reduces to two parallel lines. You could see we just reduced it to two parallel lines. I don't know how you can visualize that on the conic section, so never mind that because I don't see how it can do that. I'll think about that, and if I come up with a solution there, I'll let you know. All right, that's it. Long enough. Hope that helps. If you follow any of that, great. But at least you can see Wolfram Alpha's correct. I don't know what he's talking about with the discriminants. It didn't work. Talk to you later. Okay? Bye. Bye.